Hi guys, how are you? I hope you are doing well. This is the last section in chapter 8. In this section 8.3, we're going to estimate the probability of success P in the binomial distribution. So let me first remind you what's a binomial distribution. So again, binomial distribution, there are two possible outcomes, either success or failure. So we have n, that's like the number of trials, right? So we have the p, that's the probability of success. Q, of course, that's 1 minus p, and that's the probability of failure. Right, and of course R, that's the number of successes. Okay, so now so let's suppose we have a binomial distribution, and then we suppose that the probability of success P is unknown. We don't know the probability of success P, so P is unknown, and we want to estimate the probability of success P. Okay, so we want to estimate P, the probability of success. Okay, so what we're gonna use to estimate the probability of success P, we're gonna use P hat, which is actually equal to R over N. Okay, so this P hat actually is called the point estimate, called point estimate. Okay, so it's like an point estimate. It's like an estimate for the given sample, estimate of P. Okay, and Q hat, of course, would be 1 minus P hat. Okay, so then we're gonna use this point estimate P hat, okay, to compute the confidence interval of P. So then a confidence interval of P is given by P hat minus the margin error E, P hat plus E, and the E, so where the error E, so the error E is equal to, so we're gonna use now the critical value, so the error E is equal to the Z sub C, the critical value using the standard normal distribution, times the square root of, so P hat times Q hat over N. Okay, so the square root of the whole thing here, so the square root of P hat times Q hat over N. Okay, so the Z sub C, so Z sub C, that's the critical value that we used in section 8.1 to estimate the population mean when the standard deviation is known. So this is critical value. So as section 8.1. Okay, yeah, so using the standard normal distribution. Actually, in the bottom of the page 2 of the the table 3, the table of the z-score, you can find, so the table of the z-score in the second page in the bottom. So in the second page in the bottom, so you can find again, the values of critical values for given confidence interval. So for example, so if you have 90% confidence interval, then the z, the critical value z sub c would be 1.645. Okay, so let's say if you have 95% confidence interval, then this critical value would be 1.96. If you have 98%, then this is actually 2.33. If you have, for example, 99%, then this critical value would be, I think, 2.58. Anyway, you can find these values in the bottom of the second page of the table of the z-score. Okay. And so that's the main formula. So this is the formula for the margin error E. Okay, so it's given by the critical value z sub c times the square root of p hat times q hat over n. Okay. So let's do an example. So let's say you have a random sample of 188 books purchased at a local bookstore. So we have random sample of 188 books purchased at a local bookstore. Okay, and let's say out of the 188, 66 were murder mysteries. So we're murder mysteries. Okay. So let's say P. Let's say P is the proportion of the books sold by the store that are murder mysteries. Okay, so that's proportion. So P is the proportion of books sold by the store that are murder mysteries. Okay. So in this question, so we want to estimate P. So we want to estimate the proportion of the books that are murder mysteries. Okay, estimate P. Okay. Well, first, so here in this question we have this random sample of 188 books, right? We have this random sample of 188 books, and we know that 66 were murder mysteries. So here, this is so first, this is a binomial distribution, because if you take a book. Now, so a book is either a murder mysteries, right, or it's not. Okay, so this is a binomial distribution, right? Because there are two possible outcomes for a book: either it's a murder mysteries or it's not, right? Now we want to estimate, the proportion of books that are murder mysteries. Okay, but now we have this random sample of 188 books, right? So in this question, so what will be the number of successes here? So success here is that a book being a success. So success here so this is when a book being about murder mysteries. Okay, so what will be the number of successes here? So out of the 188, so the 188, that's the number of trials. Okay, so that's 188. So what's the number of successes here? We have 188 books, right? And we know that 66 actually were murder mysteries. So the number of successes here is 66. So R, the number of successes, that's 66, right? So what will be the point estimate in this question? So the point estimate p hat, so we said p hat, the point estimate would be r over n, so the number of successes over this, the number of trials, which is 188. So number of successes here we have 66 over 188, so that will be equal, of course, to 0.35. So that's the point estimate, okay? And of course, then q hat would be 1 minus p hat. So it's 1 minus 0.35, so it's 0.65. Now, let's say we want to find, so we want to estimate P, the probability of success, or proportion of books that are murder mysteries. Okay, so let's say I want to find a 90% confidence interval. Confidence interval of for P. Okay. So so the confidence interval would be, so the confidence interval, so we said is given by p hat minus e, the margin error, p hat plus e. Okay, so where e, so what's e? We said e is a critical value z sub c times square root of p hat times q hat over n. So first, what's this critical value here? Well, it's 90% confidence interval, right? So it's 90% confidence interval. So we said for 90% confidence interval, the critical value z sub c is 1.645. Okay, so here, so z sub c, that will be 1.645 times square root of, so we have p hat. So what's p hat? So the point estimate p hat. So p hat is the 0.35, right? And q hat is 0.65. So that's 0.35 times 0.65, right? Over n, and that's the number of trials. So we have 188 sample of 188 books. So over 188 here. Okay, so then, so first, guys, here when you do the operation here, so we first multiply here at the top, then you divide, and then you take the square root of the whole thing here. Okay, so then actually this margin error e would be equal to 0.06. So that's e here. Okay. So then we are almost done. So then the answer, the 90% confidence interval for P is, so we said it's P hat minus E, P hat plus E. So P hat, we said it's 0.35 minus the E, the error, 0.06, 0.35 plus 0.06. So that would be equal to 0.29, 0.41. Okay. So what will be the interpretation of this answer? So again, we are, so it's a 90% confidence interval for P. So it means that we are 90% certain that a book sold by the store is murder mysteries. Okay, so we are 90% certain that book sold by the store is murder mysteries. Right. So that's how we get this confidence interval or estimation for the probability of success p in a binomial distribution. Anyway, guys, I guess I'm gonna stop here, and you can find more details, I guess, in the lecture notes. Thank you. I'll see you next time.